All right. We should be live in theory, but people are going to have to let me know. And yeah. So the rain, it's raining again. We had a beautiful sunny weekend, and now we got rain again. So of course we do. It's not that loud though. It's a light rain. It's a standard West Coast light rain as opposed to a torrential storm or a hailstorm. Yeah, West Coast weather. It's beautiful in the summer, wet in the winter. So yeah, I'm on the surface of Mars right now. Hope you enjoy that. Actually, this was leftover, the green screen leftover from my interview on Friday with the Perseverance rover researcher that I talked to. I hope you got a chance to watch that interview. It was great. I really enjoyed it. A little housekeeping. We've got, let's see. So on Friday, I'm doing an interview again. This one's at 9 a.m., but it's an interview with a researcher about the pulsar timing array, which is using pulsars to detect gravitational waves, which is going to be pretty interesting. And then, and I'm coordinating an interview with somebody super important from NASA. I'm not entirely sure it's going to entirely pull through, and it might not be a very long interview. Probably 45 minutes if I can pull it off. So we'll see. It's the Jim Green, who's this? All right. So you know how this works. We'll spend about an hour. I've got a couple of prepared questions. I've got 6, but I'm not sure how many of them I'll use. I'll sort of decide as I feel how things are going. Then I will shift over and do your questions. Buffering. Let's see. Is it back? Totally buffering? It says it's an excellent connection from YouTube, and I don't see any dropped frames in a while from... Okay, all right. So we're now recording this locally on my camera and then uploading it. So if it does have a problem, the final version that we render out will be good. Right. So then we'll answer your questions, yak for about an hour, and then I'll probably shut down the recording, and then we'll shift into overtime and however long I have energy. So, all right. Yeah, let me know if you lose the stream, and I'll try and stop and wait for it to get better. Okay. I will start the recording. That's recording. Start the audio. Okay, the audio is recording. And I got a new location for my microphone, which is much better than it hanging down in front of me. So hopefully this will work better. Okay. Hey everyone, welcome to the question show. Your questions, my answers. As always, if a question pops in your brain anywhere across my channel, just write it down. I'll gather a bunch of them up and I'll answer them here. I record the show every Monday at 5 p.m. Pacific time, live in front of a internet audience. So if you want to watch this, you want to come join, ask questions live, I'd love to have you hang out with the rest of the people. And it's a good sort of back and forth and lots of follow-up questions. It's a lot of fun. Now, a couple of weeks ago, I mentioned the newsletter, which I'm hoping you subscribe to the newsletter. But the other thing I want to recommend, of course, is the podcast that I do. So if you're too busy to watch YouTube videos, and seriously, like, who has time to watch YouTube videos? Then I highly recommend you subscribe to my podcast. And essentially it's just an audio version of everything that I do. So all the interviews that I do with other people. So if people want to ask me questions and have me on their show, I'll usually try to pull off a copy of the podcast, their podcast and add it to my podcast. And so if you want to hear more like behind the scenes or like my story or just like what we're working on with Universe Today or some of the other kind of more philosophical stuff, sometimes those are pretty entertaining. So you might enjoy that. So just do a search for Universe Today podcast or go to universetoday.com/audio and you can sign up. All right, let's get into the questions. All right, so we will do the, buffering again. No. Okay. Yeah, it could just be Starlink. I mean, come on. I am recording this show from a trailer in a West Coast rainforest. Anything that is possible blows my mind. TV Secret, did you catch any of the Aurora Borealis? No, this time I didn't. So the one back on the 12th was fantastic. This time we checked a bunch of times. I set up remote cameras to try and scan the sky, and we were sort of sitting inside, and then every now and then we'd sort of turn on the camera to see if there's any aurora display. Nothing. So, I didn't see a lot of people had any luck with this one. So maybe it was just a glancing blow, didn't really hit the Earth as strongly as the one that hit us on October 12th. So, unfortunately, it just didn't work very well. So, but being you miss 100% of the auroras that you don't stand outside trying to watch. So, you just got to keep running the numbers, and every now and then you get the one that blows your mind. So I'll try again on the next alert. But we're moving towards global or solar maximum, and so we're going to have more activity, more flares, more coronal mass ejections. So it should just get better and better. All right. A bear is playing with the uplink dish. Okay, here we go. HPA 97. Would it be possible to have a sphere of liquid like water that can maintain its shape without having a rocky core while also being stable and not evaporate? There were a bunch of questions in there, so I'll try and kind of break it into its component pieces. So if you had a planet's worth of pure water just hanging out in space, would it form a sphere? And the answer is yes. The mutual gravity of all of the water would hold together and form hydrostatic equilibrium, just as if you had a planet made of rock or anything. Gravity is gravity. It wants to pull things into a sphere, and it would do that with a sphere of water. But it wouldn't be this sort of perfect floating sphere of water. It would be this weird thing, because you would have on the surface, you would have like, if it's, in the cold of space, it would be covered in a thick layer of ice. And then beneath that, you would have some point where the water hadn't frozen yet. You'd have like an ocean. But you'd also have this incredible pressure and temperature. And it would get hotter and hotter and hotter as you move to the center of this sphere of water. And so you would form these weird versions of ice where, like, for example, we've learned that you have ice inside Neptune and Uranus that is under such pressure and temperature that it actually acts a bit like a metal and can form the magnetosphere around these planets. So it could very well be that you get a magnetosphere forming around this planet of water. But it would, if it's pure water, you're not going to have any of the really heavier elements. You're really just going to have oxygen and hydrogen, and that's that. And so it would be tricky to have any kind of life form. You'd need some heavier elements, some kind of rocky core, carbon, whatever. And in fact, there's been a lot of thinking about that, and this is like a total tangent, but there's been a lot of thinking about like how habitable would be a world that has a very thick layer of water, like one that is maybe hundreds of kilometers thick before you get to the rocky core or the rocky layers down below. And there's arguments kind of going back and forth on whether or not you could have life at all, because it's just so far removed from the nutrients to where the water is, or to where the sunlight is. I'm gonna record that again, Chad. It's just so far removed from where the nutrients are to where the sunlight is providing energy. But would it not evaporate? And that really just depends on how far away it is from a star. And so if it's really far away from a star, say out at the orbit of Saturn, then no, it won't evaporate. Just like Enceladus doesn't evaporate. But if you moved it into the inner solar system, put it at, say, the orbit of Earth, then yeah, it would evaporate. The sunlight would be constantly beating it up, would be tearing apart, heating, it would be sort of sublimating the water off the surface, the ice. It would be blowing it away off into space, and it would get slowly smaller and smaller. I'm not sure like how quickly it would happen, but it definitely wouldn't last forever if it was close to a star. Poltuk. If we're alone in the universe, is it our duty to send life to other star systems before we go extinct? Yeah, this is an idea that I think a lot about. And honestly, this is one of the ideas that got me so enthusiastic about space exploration and astronomy when I started Universe Today about 21 years ago. And just this idea that, what if we're alone in the universe? Like, obviously, everyone always says, like, there's no way we're alone in the universe. But what if we are? What if we're the only place that life is formed? Does life make the universe better? I mean, obviously, it has its problems, has its faults. But I think most people would agree that having life in the universe is better than having not life. That pandas are better than boulders. That whales are better than silt. So I just feel like having life in the universe makes it better. And so then if we are alone, and we're the first technological civilization to reach this point, then do we have a moral obligation to help life spread across the universe? And I think we do. Like, as I mentioned in a couple of episodes ago, that we've only got, say, 500 million years before the sun boils the oceans off of planet Earth. And maybe we've gone extinct, but maybe we used up all the metals and the oil and all of the easy access to various minerals and stuff. And so then when the dolphins rise, they don't have anything to work with. And then when the octopuses rise, they don't have anything to work with. And so nobody can achieve a spacefaring civilization. It's up to us. And so I think that's, if I sort of think about like the biggest priorities, like what should we be doing? We should be searching for life to just find out if we are alone in the universe. And amazingly, that is a scientific question that we could answer, because the larger a sphere of the Milky Way that we explore and examine and don't find any evidence of life, then the less chance there is of life being common in the universe, right? If we examine a sphere of the Milky Way that's 1,000 light years across, and we've got such powerful telescopes that we don't see any biosignatures on any of the planets orbiting any of those stars, then that's a pretty good sample of the Milky Way, and it tells us that life is either extremely uncommon or we're the only ones. And so the priority is to search for life. And if we continue to not find life, then the second priority is to make sure that we don't go extinct. And I would say the highest priority of that is to take better care of Earth, because we are ruining the best place in the universe. And then once we've made sure that we're taking good care of Earth, then let's do a good job of spreading out across the solar system. And maybe we do those two things, we can walk and chew gum. Let's take good care of Earth, and let's explore the solar system and get all of our eggs out of this basket, and let's figure out a way to potentially move to other star systems. So yeah, I personally think it is our duty that the universe is made better with life, and let's share the bounty that has happened here on Earth. Okay. Let's see. So I got a couple more questions. Okay. Jeremy Harris. Could an advanced future civilization cheat the heat death of the universe by creating energy from tidal friction? For example, moving moons into close orbits around planets like Io and Jupiter and then harvesting the energy created. Would it be theoretically possible to do this even with objects that had already cooled to the background temperature of the universe? First, you can never cheat the heat death of the universe. In the end, the heat death of the universe will win. But you can, of course, try to prolong your existence in the heat death of the universe. And so the thing that you're describing, like, we know that, say, Io is heated to the point that it's got the most volcanoes in the solar system because of these tidal interactions that are happening between Io and Jupiter. And Jupiter is flexing Io back and forth and kind of squeezing and squishing it and warming it up. Same thing is happening with Europa. And yeah, absolutely. If you had a planet, a giant planet floating in space, and you had a series of planets orbiting around it, or moons orbiting around it, then they would interact with each other and with the planet, and it would cause tidal flexing, and it would warm them up. But that would just be a delaying tactic. You're going to, like, the price you pay for this tidal flexion is, I believe that's the word, tidal flexing. The price you pay for this tidal flexing is that you lose orbital momentum. You lose all the variation. And so what's going to happen is eventually the planet and the moons are going to be in lockstep with each other. They're going to be orbiting around in exactly the same way, lined up in a certain kind of resonance. They'll be tidally locked to the planet, and there will be no more room for tidal interactions, and then everything will cool down to the background temperature of the universe. So every single idea that you can ever have to cheat the heat death of the universe is going to end up with the same answers, which is you can't cheat the heat death of the universe. But with energy conservation, you can imagine really clever ways. You're feeding a black hole sips of energy, you're dismantling stars, and then creating fusion based on the hydrogen that you're pulling out of them. That's way more efficient than a star just going crazy, burning through all its hydrogen and then exploding as a supernova. So there's plenty of ways that, once we get to an advanced enough level of technology, we can lengthen out the amount of time it's going to take before we run out of energy. But in the end, we have to run out of energy. Flexing or flexion, either works. Okay. All right, let me do one more. Subnet Mask. Hey, Fraser, of all the planetary bodies that we know of apart from Earth, which offers the longest survivability for a human wearing nothing but lots of layers, a really warm coat, and a gas mask? The way you described that question, there's really only one place that you could exist for a long time, and that would be on the surface of Titan. Titan, of course, has an atmosphere that's about 1.5 times as thick as the Earth's atmosphere. It has very cold temperatures, like bitterly cold, but it has that atmospheric pressure. And so you don't need to have a spacesuit. You just need to have a really warm coat. But the atmosphere is not breathable. And so you would need some kind of breathing apparatus as well. But if you had a really, essentially you're going to need to have a coat that is so complete with such heaters that it'll feel like a spacesuit, but it won't need to be pressurized against your body in the same way that a spacesuit does. So that's pretty much the only place that you could walk around outside without a pure spacesuit. But there's a couple of other places. So the other idea, of course, is that you could be in the cloud tops of Venus. You could be about 50 kilometers above the surface of Venus. And at that point, the temperature of the planet and the pressure are roughly the same as the Earth. So once again, you could stand outside on your cloud city on Venus in your short sleeves, or probably a coat. And again, a breathing apparatus because the atmosphere is carbon dioxide. And you would be fine. And then there's places that you could go that it would be a lot quicker. Like you could swim in the ocean of Enceladus or Europa briefly, and you wouldn't need to have a spacesuit because you'd be in water. You wouldn't need and the temperature, you just need a you just need like a scuba diving suit as well as some kind of oxygen mask. So you literally could take your scuba diving suit, gear up to go for a dive here on Earth, but you could go to the ocean of Enceladus. You could drop in the water there and swim around, and it would be kind of the same. You could survive briefly falling into the atmosphere of, say, Uranus or Neptune until the pressures get too great. But that's about it. But there are a few places you can go. Let me know how it works out. Okay. Let's see. David L., can you talk to us what's going on with Lucy? Yeah, we talked about this. They launched a few weeks ago. At this point, there's been no major change. One of the solar panels is clamped on. The other solar panel has not latched and is producing about 95% of the power that they're expecting. So it's fine, and maybe this is just going to have to be the reality. And David Sims in the comments said, like, what, based on 50% of the latches not working properly on this mission, think about James Webb with hundreds. Eek. Okay. Okay. Kim Barron, what would be involved in decommissioning the ISS or Hubble since they're kind of large? Right. When Hubble and the International Space Station run to the end of their lifetime and the plans are, okay, these are no longer functional. Hubble is dead. It's time to deal with it. The International Space Station it's no longer habitable for astronauts. It's time to remove it. Then they will be deorbited. And what will happen is essentially a retro rocket will fire. There's an attachment on the Hubble Space Telescope, so it's ready to have something dock with it and deorbit it. And with the International Space Station, they would probably just either fire the thrusters on the space station or dock, say, a Dragon capsule and have it fire the thrusters. And this happens from time to time. And actually, there's a place in the Pacific Ocean where all of these spacecraft go, if they can do it. Sort of this big chunk of the ocean where there's no islands, there's no population. The chances of anybody having any problems are very low, and they will deorbit it through the atmosphere and crash it into the ocean. And with these larger objects, say the size of the space station, the size of Hubble, etc., lots of this will survive the entire atmospheric reentry and plunge into the ocean. And if you don't do that, then some of these larger satellites, it's just random where they crash into the Earth. So, in most cases, when countries are being responsible, they build in the deorbiting capabilities so that they can crash into the Great Pacific Graveyard when at the end of their lives. And for some countries which have not been responsible, they have crashed them into Canada and Australia. And sometimes they get lucky, or mostly they get lucky, and they crash them into the ocean. But, do you really want to be responsible for having your satellite crash into a population? So most of the time, people set up deorbiting capability on the space station or satellite. I'm going to answer Trey Harmon's question. Okay. Trey Harmon. Hey, Fraser, could the hypothesized Planet 9 be explained by our sun actually having a dim binary sibling that we haven't yet identified? Just a crazy thought, maybe a distant brown dwarf. That's a good question. It's not a crazy thought. And in fact, NASA launched a mission called WISE that its primary job was to search for brown dwarfs in the vicinity of the sun, the solar system. And using WISE, they were able to essentially rule out any objects the size of Jupiter or Saturn in the outer solar system within about 50,000 astronomical units of the sun. So we know for sure that there is not a Saturn-sized, Jupiter-sized, brown dwarf-sized object out in the outer solar system. That leaves a Neptune-sized object that is closer, and that's what Planet 9, if it is out there, has to be, or smaller. Yeah. Australia did fine the U.S. for littering space debris. We had a Russian satellite crash in Canada and spray uranium, plutonium around the Arctic, and I don't think we've been compensated for it. Although it is still an issue. It's still up there. It's still radioactive, and people still have to sort of route around the debris. No, WISE wasn't at the International Space Station. It was just its own. It was a separate space telescope. Colonel Zach, if we don't sufficiently tackle the climate emergency, how will space exploration be affected in the short and long term? I like that term, climate emergency, climate apocalypse. Like I don't like climate change or global warming. They just sound too tame. So I've been mulling around different catastrophic terms to use for this, just to really kind of hammer it home. So how would space exploration be affected by climate change? Well, obviously, the Kennedy Space Center is built on low-lying swamp in Florida, which would be inundated by the oceans. So you can imagine, and a lot of the space centers are built near oceans. So you can imagine that would be an issue. But I think larger, you're just dealing with the economic implications of having to pour money into building dams, building dikes, dealing with water, dealing with drought, dealing with repopulating people that are having to evacuate various regions. Like, it's just like going through, it's like a war. Like when you have a war, all you're focused on is basic survival. And it's only once you've wrapped it up, you can actually start to get back into a growth stage of your economy. And I think it's going to feel a bit like a war in the coming decades. And that just means that concentration is going to be off things like space exploration. And so, that's the worst case scenario. The best case scenario, of course, is that the world's nations decide to agree on the various summits that they've done, and they draw down the greenhouse gases and meet the 1.5 degrees Celsius climate targets, and the climate of the Earth is not too dramatically changed, leading to various repercussions, and then we don't worry about it. So I guess it just kind of depends on how bad it is. I think that, like, one of the great things about space exploration and just like this kind of work is that it teaches us a lot about the Earth. I mean, think about all of the rockets and satellites that are doing Earth observation. I mean, we wouldn't know the state that we're in without this space technology. But also just like all of the research that's happening with astronauts, trying to keep astronauts alive in a closed environment. There's a ton of value in just learning. Like I loved the Biosphere 2 experiment. Like, I know a lot of people kind of laughed about it, but just this idea of attempting to close up an environment and then figure out where it breaks, where it runs out. What do we not understand about how the environment works? That's incredible. It's so important. I mean, literally, if we try to build a space station, we would need to learn all of that knowledge. Why not just do it here on Earth? So Yeah, I know I'm kind of rambling. Climate emergency. Depends on how bad it's going to be. Space exploration will teach us a ton about the climate, about the Earth, about how to live in a more environmentally protective way. And I hope we don't have any sort of bumps in the road along this path of space exploration. James Dubbin had to step outside and watch the Hubble go over. Nice. That's awesome. Did you get an announcement that it was going to happen? Yeah, Biosphere 3. Let's do that. Sean Marsden, someone invented a matter transformer consisting of 2 units, like a phone booth. You place one transformer into the other. Where would it go? Well, it would be destroyed without the receiver. Okay. TP Seeker. Was it a type of mold bacteria found on the outside of the ISS, and would it be considered an alien life form? There was this rumor going around a couple of years ago that Russian cosmonauts had found some kind of bacteria living on the outside of the International Space Station, and I think it was debunked. I haven't really sort of been keeping track of it. So, but that said, there have been actual experiments, and I've done a video or two on these. There's been experiments that have been flown to the International Space Station where they took like the hardiest life forms of Earth, opened up the doors, and exposed these life forms to space for years. The hot, cold temperatures, the vacuum of space, the dryness of space, the all of the radiation from space, and then they closed it up and brought these life forms back to Earth, and some of them didn't do so great, and others were able to survive and even thrive. So it shows that we have life forms on Earth that are perfectly able to fly to space and be on, say, the outside of the International Space Station and still be fine. They wouldn't grow, but they could be in a state of hibernation and then grow later if they were able to make it back down to Earth. So you can imagine, like we were talking about earlier in this episode, right, that you've got, some bacteria has made it to the outside of the International Space Station, and then the International Space Station crashes back down to Earth in 10 years when it's deorbited, and the life forms on the outside, they reach the ocean again, they're like, time to get back to work. So life finds a way. Tardigrades we got put in space. Meh, it's fine. Yeah. Physics police. Any limits on the albedo of possible Planet 9? I don't know I don't know what the actual limits are. I mean, of course, there's going to be a limit because, depending on what it can be made out of, right? If it's pure ice, if it's got like an albedo close to 1, like Enceladus, then doesn't have to be that large before it starts getting bright and we'd be able to see it. But if it's very dark, like the moon or Iapetus's dark side or something like that. But I don't know what the actual, I'm sure the people searching for it. I mean, like the hope is like next year, 2022, Vera Rubin comes online and we get all these questions answered for us. I can't wait. Like I've never been so excited for a mission or for a telescope or anything until Vera Rubin. Vera Rubin is just gonna give us so much information about the night sky. Like I could do a show. I'll be able to do a show. I could do a Gaia show. Like every week I could give you a rundown of all the new discoveries made by the Gaia mission. And I'll bet you we could do the same thing with the Vera Rubin. There's that much stuff just getting disgorged from these incredible telescopes. Sammy Parson, how long would it take traveling at light speed to reach Alpha Centauri? It would take 4.3 years traveling at the speed of light, because that's how long light takes to get to us from Alpha Centauri. Mark Carter, could that cause James Webb to be halted? No, James Webb is going to launch. Even though there's this problem with Lucy, I'm sure it's a totally different mechanism, right, than all of the actuators. And they've tested all the actuators. I'm sure they tested the actuators on Lucy too. But no, James Webb it's done. It's in the can. It's about to get attached to the top of its rocket, and it's going to fly. There are no more delays. Like, you could play this game forever, where you're just like, did we double check this? Let's unfold James Webb one more time and make sure that all its actuators are working. No, it's done. Way it goes. And Mitch Harpino, right? All the delays in prep. How confident is NASA with James Webb going off without a hitch? They're as confident as they're willing to be. So they could spend more time and more money and become more confident, but at a certain point, you just have to roll the dice, and that's where they're at. Arjun, have you interviewed the person involved in the James Webb folding? If not, maybe he can assure us that it will be fine. Yeah, I mean, I talked to the engineer last year. I talked to the head engineer, so I guess we didn't really talk about exactly the folds that's going to go on and the actuators and how he feels about Lucy. So, we'll see. I don't want to bug them. They're busy right now. They've got another 2 months, and then this less than 2 months, 6 weeks, 7 weeks, and then this thing launches. So I'll have a chance to talk to them after that. Colonel Zach, how dangerous do you think Gliza 710 will be when it heads our way? It's not going to hit. I mean, not. Space is big. Jurij Slavic, what's the latest from Ingenuity? Has it accomplished its mission yet? Cheers. Yeah, Ingenuity, the most recent news from Ingenuity was last week it did its latest flight and actually went to the highest altitude that it's gone. It went 16 feet, so just over 5 meters, which is higher than the 3 meters it's gone. They also increased the speed, so for the first time they went faster on the rotor speed, and that was part of why they were able to gain a little bit more altitude. So they've already accomplished its primary mission. Its mission was to just fly a couple of times and prove that powered flight on Mars works. So now we're well into overtime with Ingenuity, and so now the engineers are willing to test it a little harder. And in this case, they're willing to fly it higher, at a higher rotor speed, and see if they can get more performance out of it. So now it's going to be the fun stuff from this point forward. Miguel Angel Romero, speaking of sci-fi, with the coming release of the 6th season of The Expanse, what do you think about ending? I haven't read the books, actually. So my wife has, and so she feels like ending at this, based on the pace of the books, it makes sense for it to end on this season. So I like things to end. I like endings. Like what I hate is when a show just keeps getting stretched out and out and out because they got more budget, and at a certain point it's nice to just have a nice solid ending. I like this question. DHR 18. If we discover an Oort cloud or Kuiper belt in another star system, do we use those names, or is there a more generic name? I think they will be called. I mean, we've reported on the discovery of Kuiper belts in other star systems, so this has already happened. And so you'll see like a belt of icy material or a vast ring of icy material, but there isn't a generic name for these. They call them other Kuiper belts or other Oort clouds, but they sort of, I don't know. It's funny. It's like when you think about like other planets, exoplanets, other star systems, the solar system, like clearly at this point, people will need to sit down and figure out a way to nicely genericize every term in astronomy that we think about that's here in the solar system, that these things will exist in other places. But yeah, I can imagine, like, if you know, in the far, far future, you've got some, you know, the explorers have moved to this other star system and they think about their Kuiper belt. They will call it their Kuiper belt. Just like, you know, like we think about the asteroid belt. Like the asteroid belt is what, Greek, aster. So yeah, I don't know. It's weird. I mean, we didn't even know there were other planets. Like when we think about the Earth, right? The Earth is just the ground. And it wasn't until we figured out that there were other planets, that they weren't just stars in the sky, but they were actually worlds like the Earth. Or the moon, right? The moon is the best example, right? What do we call, you know, the moon? So maybe so what we do on Universe Today is we capitalize the moon, but then we uncapitalize other moons. We capitalize the universe, but we uncapitalize other universes. And so maybe we would have lower capital Kuiper belt in other star systems, grammatically. ATL 530, what's your take on orbital reef? I talked about this just last episode, but the gist is cool. More competition, more better. And NASA would probably be first in line to pay for room on the station if it's working. Let's see. Well, Lizzie, what if James Webb rocket explodes on launch? Stop it! Just like stop it! Like what if? What if? Yikes! I can't even think about it. It's gonna work. T-Home, do you think delays like James Webb will be the typical of future projects like Vera Rubin? No. I mean, Vera Rubin has not been delayed greatly. I mean, a lot of these big telescopes are not in any kind of delay. They're not in any kind of over budget. Like the extremely large telescope, the budget is like $1 billion. Like the biggest telescope ever built on the surface of Earth, 39 meters, is like $1.05 billion. And they're on target, on plan. Every now and then they increase their budget a little bit, but for the good reasons, like they've decided to increase the capacity of the telescope. So, no, James Webb was a powerful learning experience. Same thing with the space shuttle. Like I think the lesson that's been learned too many times now is that you've got to manage the technical risk. You've got to build a mission within your existing capability and then test a few new ideas to sort of build the next version of what you're doing. But you don't want to try to take on too much risk all at the same time. And that's what really happened with James Webb, is that it was going to have this sun shield. It was going to be folded up inside a satellite fairing, a spacecraft fairing, and it was going to have just like a whole bunch of things were all happening at the same time. Each one had never been done before, and you add all those together, lightweight materials, this much telescope packed into this tiny launch fairing, it just created all kinds of problems. So I think that's the lesson that's really been learned. Let's see. All right. Mayer's 12. Hey, Fraser, with the mass and dark matter, does our galaxy have an escape velocity? Oh, I should get the number. Hold on. Let me just... I forget what it is. 250 kilometers a second? That's my guess. Let me see what it is. 550. Okay. All right. So there you go. That was the first time I've Googled something in a year. All right. Yeah, the Milky Way does have an escape velocity. So let's just talk about the Earth. So if you want to try to get into orbit around the Earth, you need to be going about 8 kilometers a second. The Earth is orbiting around the sun at about 30 kilometers per second. And if you want to try and escape the solar system, then you need to be going, I think it's about 42 kilometers per second. That's like the escape velocity of the solar system from the point of the Earth's orbit. Now, we're already in orbit, so it's about an additional, let me do this again. If you're already off the Earth, you're already in orbit, and you're using the Earth's momentum, orbital velocity around the sun, then you need to go about another 16 kilometers per second to escape the gravity of the solar system. So the solar system has an escape. The Earth has an escape velocity. The solar system has an escape velocity. The Milky Way is just an object with a lot of gravity, so it has an escape velocity. And the escape velocity of the Milky Way is about 550 kilometers per second, which is a lot. It's very fast. And so you might be surprised to hear that there actually are objects which have been given that level of an escape velocity. Astronomers have used Gaia and other missions to detect objects that are moving on a trajectory through the Milky Way at an escape velocity. So the question is how? Like, how do you get a star that's moving at this kind of speed? And there's two scenarios that have been devised. One is you have a supernova. So you've got two stars orbiting around each other, and one of them explodes as a supernova and vaporizes. And now suddenly you've got this other star, which was sort of wheeling around in this gravitational hold, now is like you've had a sling, and you've just let the rock go, and it just heads off in this new velocity. But the other way is some kind of close call with the supermassive black hole at the heart of the Milky Way. And you can imagine some kind of three-body interaction where a star gets really, really close to the black hole, interacts with another star, and something gets kicked out on this incredible velocity. But yeah, there are like multiple objects that have been discovered so far that are on their way out of the Milky Way, and they're never coming back. Take another level. Universe escape velocity. If the universe was a single, like if the observable universe was all there was, then yes, the universe would have an escape velocity. But we don't know how big the actual universe is. We can only see the observable universe. The observable universe is not the whole universe. Larry Beckham, did the space shuttle ever reuse SRBs? Yeah, they did. So the solid rocket boosters were reusable. The orbiter was reusable. Only the main fuel tank wasn't reusable. But there was a ton of retrofitting that happened with each mission. Arjun, should we be putting effort into learning to talk to other species on Earth so we could talk to aliens if contacted? Did you hear that researchers are using machine learning to try and talk to sperm whales? That they've recorded mountains of whale song from sperm whales, and their hope is to decode them in some way and that we could actually try to communicate with them, which is kind of amazing. So yeah, that would be great. You know, we assume that animals are dumb, but anyone who's ever had a dog, I mean, our dog is deaf, and so we use sign language to talk to our dog, and she picks up the signs pretty quick. She knows what you're talking about. If you want to go for a walk, do you have to go to the bathroom, do you want some food? She gets it. So yeah. Okay. Science Cyclop, why are you spamming the question? So, yeah. And you're asking, can gravity form from waves? So, I don't understand the question exactly. Like, do you mean waves in the ocean? Do you mean like waves of energy? So let me see if I can give the So obviously waves in the ocean, waves are made of matter. Matter has gravity. So yes, waves in the ocean can create gravity, but it's really just the water being pushed around. But are you wondering about like waves of energy? Then yeah, photons theoretically have gravity. And so if you had a whole bunch of energy, a bunch of radiation, then it would form gravity. So I don't really understand the question. That's the problem. Yeah, Google Translate from English to whale song. Perfect. Yeah, I think that's what they're trying to get to. Apparently whales swear a lot. That's awesome. Yeah, they're filthy. Yeah, okay, so Beacon Nisham, what's the fastest thing? So I don't know what the fastest. Let me see. I'm just gonna Google this one for you too. Fastest star escaping Milky Way. So as I said, 550. So 6 million kilometers per hour. It's a hypervelocity star. Yeah. So what is 6 million kilometers per hour in kilometers per second? Okay. Henrik Nielsen, why do you all believe in the Big Bang? I do not understand. Which part do you not understand? Do you not understand the mountains of evidence that confirms the predictions and calculations made about the Big Bang? The up to, I think there's like 10 independent lines of evidence that support the theory of the Big Bang. The ratios of the elements in the universe, the fact that objects are moving away from us in all directions, and like a bunch more, the cosmic microwave background radiation, and I don't know all of the lines, but there's mountains of them. So, each one is beautifully supported by tons of experiment and research. And so, it's like my guess is that somebody, possibly with some other explanation for how the universe works, that maybe comes from a book, finds that the idea of the Big Bang confronts or is, against that idea. And so you have this problem, which is that your book says that the universe works one way, and all of the evidence collected by scientists says the universe works a different way. And so then the question is the book, which cannot be wrong, or are the scientists wrong? You have to, say that the scientists are wrong, I guess. It's what you say, or what people say. But the point is that you have to keep an open mind. You have to just say, like, we will never know for sure anything about the universe. All we can know is sort of, we can be less wrong over time. And the way you're less wrong is that you perform experiments hopefully with as sort of a lack of, like you're not trying to have the, confirmation bias. You're not trying to have the outcome conform to what your expectations are. You just perform the experiment and see what happens. And that works with evolution, and it works with the Big Bang, and it works with all kinds of things. Here we are, broadcasting on the internet thanks to an innumerable experiments performed by people over time using various metals and materials and electricity and so on and so forth. So, yeah. So it's, like all we can do is believe in whatever has the most evidence, but also freely change your mind when something comes along that has more evidence. So, generally if a person says like, I don't believe in the Big Bang, then they kind of don't understand the theory. And so the best thing to do, if you have a thing that you don't believe in, then the best thing to do is learn all you can about this thing that you don't believe in to be absolutely sure. So at least you can form a much better argument when you are confronted with the evidence that people have for this thing. And so my recommendation is read a bunch of books like Stephen Hawking, Brief Moment in Time. There's tons of great books about the way the Big Bang works, and they all lay out very carefully what the evidence is for the Big Bang. And I think you'll find that very enlightening. Okay, so just got time for like one more, and then we'll kind of shift into the overtime. Puffy Cheeks, do we know what James Webb will look at first? I don't remember. Actually, one of the interviews that I did a few months ago was one of the people who's responsible for choosing the targets for James Webb. So maybe do a search on my channel for James Webb, and you should get that interview. See. There you go. First 3 minutes by Steven Weinberg. That's a good one. Yeah. A little background. Can you rest a background with dinosaurs or the sea with killer sharks? Yeah, that'd be great. I tend to change my background to be whatever is the theme for the interview that I'm doing. So maybe my background will be a pulsar on Friday. All right. Samurai Hash. Would you rather have Earth as a nature preserve or make many large O'Neill cylinders as nature preserves? Why choose? I mean, I think that life is better with nature being preserved. Like people live in cities. I mean, maybe there's a few people that just love the glass and steel and concrete and driving beeping cars and ambulances and fire trucks and all the noises and the pollution and all that. But my guess is people live in cities because they have to, because that's where the jobs are. You put up with it. Yeah, there's all kinds of cool cultural things that happen in cities, but life is made better with nature, with access to trees and oceans and rivers and animals and wildlife and all that kind of stuff. So I think that the hope for space exploration is that we can push a lot of the polluting heavy industry off of Earth and out into space, and then we can try to let Earth just become the best place for life, including human beings, but hopefully we can have a smaller footprint on the planet, and then we can just pollute the space. Who cares, right? It's just, there's all it's just rocks and starlight and, lots of space out in space. But then, would O'Neill cylinders make nature preserves? No, I mean, they would make, the technology that's going to be required to keep a biosphere going in orbit. You're going to have to deal with the temperature, with the pressure, with the radiation, artificial gravity, energy. You're going to have all kinds of machines that are keeping everything going all the time. So it's going to be incredibly difficult. Not dying in space is an incredible accomplishment. Now, who knows? In the future, hundreds of years from now, our technology may be so good that we trivialize living in space, and then maybe we can perform some interesting experiments. We can have places that are like the best savanna or the best desert or whatever out in space, and try to preserve the various wildlife that we have here on Earth. Because over time, Earth will try to make everything go extinct, right? 99% of all species that have ever lived have gone extinct, and Earth is just going to keep that up. So maybe we will sort of start preserving life forms off Earth, but that's going to take a long time. All right, those are the questions this week. That was a lot of fun. As always, I do these shows every Monday, 5 p.m. Pacific time. So if you want, come hang out, ask your questions live. We'd be glad to have you. And we'll see you next week. All right. Okay. More questions in a second, but first I'd like to thank our patrons. Corey Chapman, Ben Galvin, Dennis Van Lind, Bill Hamilton, Choo Choo, and the rest of our 781 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. And then the outro. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all of my videos are also available in handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcast. And I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano. Okay, stop the recordings. And that recording. Okay, awesome. Quickest hour of the week. All right. Let's go. After show. Marcus answer for Q. Okay. Mad Ben scientists explain how the Oberth effect works. Not exactly. I mean, the Oberth effect. Man, but isn't that like taking a trajectory? Yeah, okay, so so it's a trajectory that you go with a spacecraft where you fall into a gravity well and then you fire your engines at the right point, giving you more speed. So, use of reaction engine at higher speeds generates a greater change in mechanical energy than its use at lower speeds. So, engines have sort of the best velocity for firing their engines, and so at higher speeds they give you a greater change than at lower speeds. You take advantage of that by doing an orbit around a planet. I should learn more about it. Since the Voyager missions are in interstellar space, can either of them detect anything regarding the Great Attractor? Like, what is it about the Great Attractor? Like that is a solved problem. It's a bunch of galaxies. We can see them thanks to infrared telescopes that look through the Milky Way. So, we didn't used to be that the zone of avoidance was this area of the Milky Way that was clogged with clouds and dust. And if you're trying to do any observations in that area, there was nothing to see. But thanks to infrared telescopes, we can now see, like Spitzer, we can see right through the Milky Way and see the big cluster of galaxies that's on the other side. And that's what the Great Attractor is. And so, no, Voyager wouldn't be able to tell us because it's not very far away and it doesn't have very good, cameras on board compared to giant infrared telescopes here on Earth. But it is funny. Like, it's funny to me. Like, maybe it's a YouTube thing that it is still like pulled out as this crazy mystery that what is it, right? The 10 greatest mysteries in space, the Great Attractor, the Booty's Void. What are these things? But we all have answers for these things. The Axis of Evil. Gordon Chin, how did the iron on Mars get oxidized if there's no life to create free oxygen in the atmosphere? So there's tons of oxygen on carbon dioxide in the atmosphere, so you can absolutely oxidize pulling oxygen out. Also, there was times in the past when there was there's water. There's probably more carbon dioxide. It's carbon and oxygen, and the oxygen can be used to oxidize the rocks. And then times there was water. So the Great Attractor is a big thing to the Tinfoil Hatters channel complex. Yeah, lots of older articles. Like, I think it's a very handsome. Yeah, it's a very handsome cluster of galaxies. But it is really funny to me that there are these. I mean, I guess you sort of like there is this YouTube science explainer information mill that is putting out content by people who don't fully understand what it is that they're talking about. And they picked up a book by Carl Sagan from the 1980s. Right? Quasars. What are quasars? We don't know. They're a mystery, but they're bright and they're really far away. We know what quasars are. Double D will get a video of the tour of the new studio. Yeah, absolutely. Once we're finished construction, I'll definitely do a video tour so you can see what the new studio is going to look like. But the gist is a big room. It's 14 feet high. It's like 35 by 35 is the main studio area. And then there's a smaller recording studio that's well insulated, sound insulated. That's where I'm going to probably, do a lot of the live streams and stuff like that. And then there's another room that's the same size, kind of like 12 by 12, which is where I'm going to set up all my computer gear. And one will be kind of a spare bedroom. So if people come and stay with us, they can stay there. If we want to shoot bigger things, we can do it in the big open area, or, we'll be recording in the actual studio part. So yeah. It's cool. It's going well. We had today 2 excavators, a bobcat, a dump truck, rolling nonstop today, as well as 2 builders actually working on the actual house. Oh, and the plumbers were here roughing in all the pipes. So it's coming along, which is good because we waited a long time. Nelson Fernandez, can you see city lights from the moon? I don't think so. I don't know. I actually don't know the answer to that question. Let's find out. Let's see what. Right. Okay. So we've never tried. Yeah. So we don't know. The problem is that all of the missions to the moon were done when for the first time, the Apollo 11, Earth was in daytime. I'm trying to think. And so then I don't know. I wonder, eventually. What's the Miguel Angel Romero? What's the mouse situation with the mouse in your trailer? No new chewed cables. So we pulled 10 mice out of the trailer in 2 days, about 5 days ago, and they were all little guys. And so my theory is that some mama had made a nest and was raising a bunch of babies inside the trailer, and then they all came into the main trailer within a couple of days of each other. Literally, I was, we were using live traps, and so I capture them and then I put them in the car, and then we go for a little drive about 4 kilometers away, and then I release them into the forest, and then there's someone else's problem. But it was just click, another mouse, click, another mouse. And yeah, we counted 10 in 2 days. And so I think it was just one big batch of babies who had grown up and they were starting to explore on their own, and they just couldn't resist the peanut that we had in the little trap. So we haven't seen any since. So it's being managed, I guess. Like, they keep showing up, we keep trapping them, taking them farther away, and it sucks. I can't wait to not be worrying about all the stuff. Like, it's funny, like we're using propane to heat the trailer, and the propane ran out in the middle of the night, and so like the trailer just starts to cool down and cool down and cool down. There was like -3 out, and I couldn't go and get new propane until the morning. So now I've got a new way. I've got a spare propane tank. I got a new way that I'm going to be swapping out the propane tanks so that we'll never have that happen again. We had condensation starting to form on the walls and starting to like form mold, and so I went out and bought a dehumidifier. Now we run the dehumidifier and keep the humidity levels down to the point that it's not going to keep causing problems. Like, it's just troubleshooting nonstop. It feels a little bit like I'm you know, on the space station where you're having to deal with maintenance issues all the time just to sort of keep yourself alive, and you take for granted just like space and the ability to like water. Like, we don't have our well hooked up yet, so every week I go into town and I fill up a bunch of jugs of water and then I pour them into the trailer, and then we have about 100 liters to last a week, and that seems to be the amount that we use if we're pretty careful. But like, that sucks. So, like, I much prefer you just turn the tap and water comes out. You know, you don't want to know what we have to do with our with the bathroom. So yeah, it's I can't wait to be out of the trailer. The Mouse Catcher channel. I've seen the channel. Mice are stealing my propane. Yeah, I've seen that channel, and like, I think once you watch a couple of them, then boom, I'm getting mousetrap ads across every website that I go to. I built one of these buckets, you know, that you put a can on and then the mice fall in it. It catches a bunch. Like, apparently there are, like an individual mouse has like an acre as a range, and there can be something like 16 mice per acre of these deer mice. And so, yeah, they're the native mice. So the problem is, the deer mice, they're adorable. They're just so cute. Let's see if I can show you a picture. I took a picture of one the other day, and they're just like, oh my God, they just are the best. Here, let me see. But the problem is that they can carry this disease called the hantavirus. Yeah. I don't know if you can see the little guy. Will it focus? There we go. So he's eating his little peanut that we gave him. He liked that while he's waiting in his trap, waiting for his ride out of town. So they have this. They can carry this disease called hantavirus, and it's bad. Like, something like 30% lethal, and so you don't want to be living in a place that has deer mice that are peeing and pooping, and you got to get them out. So that's what we're doing. Yeah, exactly. Hantavirus. Yeah, so you don't want to mess with it. You gotta trap them at the source, and so we like blocked. Like, I crawled around the underside of the trailer and used spray foam to just block every single entrance I could find. We've covered every little entrance, every way they could be moving around from place to place in. And at this point, they have like one way that they get in somehow, and then we've got the trap set right in the beeline for that, and they all fall into the trap. So for now, I think we've got it under control. But yeah. The deer mice, no, they're tiny. They're little. You're making many memories. Yeah, that's how it works. Yeah. Yeah, it's my Biosphere 3. Darsh Bahani, what is the advantage of X-rays? Because NASA's launched the Chandra Space Telescope. Yeah, so X-rays are actually an incredibly important way to view the universe. I was talking to an astronomer, and they were saying that in fact, the vast majority of the universe is best seen in X-rays. Like, all of the space in between galaxies is filled with hydrogen at various hot temperatures, and so it can only really be seen by the X-rays that it gives off. And so you need something like Chandra, these other X-ray observatories, to map out the spaces in between the galaxies, the largest areas in the universe. You can only really see them with X-rays. So astronomy would be so much worse without X-ray telescopes, and they can only be done from space. The atmosphere blocks X-rays and gamma rays, which is good, thankfully, but because otherwise we would get cancer from it. But you need to have a space telescope to be able to even observe them at all. So Chandra was a game changer. Shadowmast, tell me the James Webb launch is going to be okay. I just need to hear you say it. It's going to be okay. It's going to be all right. James Webb is gonna fly. Like there's gonna be like one delay. They're gonna be a little concerned about the weather, so they're gonna hold off and they're gonna use their next window, and then they're gonna fly, and it will start working and start deploying. Everything's gonna be great. There you go. So what part of the studio will you live in? Well, we're gonna live in the whole thing. So, what is this? The big open space, that'll be our living room and kitchen, and then one of the things will be the bedroom, and then the other one will be the office. So we're going to be living in the studio and then break ground on the house. 23 is when we start on the house, but it's a house for me and Carla, so it doesn't have to be too elaborate now that the kids have moved out. Mods having to work extra hard tonight. Thanks for getting rid of all the nonsense. Yeah, I didn't even see what was going on. So thanks, mods, for dealing with whatever was going on there. Normally it's not so bad, but I guess this week it was rough. So, all right, I'm getting hungry, so I think I'm going to wrap this up. But again, thank you everyone for hanging out today. Big thanks to the mods and Nancy for staying on top of everything. As I mentioned, on Friday, I'll put the event in, but on Friday, 9 a.m. interview about the pulsar timing array. So measuring gravitational waves using pulsars. Like, how sci-fi is that? And then hopefully I'll be queuing up this interview with Jim Green or someone from the team to talk about NASA's new proposed approach for searching for life. So we'll be talking about that. All right. Thanks, everyone. And we'll see you all next week.